Okay, so welcome to Physics 121 Lab. I'm just going to discuss sections of the syllabus. I do want to show you this picture I put up there, though. Look at the poster. Prevent aging. Traveled for years to the outer planets, returned hardly a month older. That's actually true. Unfortunately, in order for that to work, you need a rocket that will travel at nearly the speed of light. But we'll learn about that in Physics 221, so make sure you take Physics 221. Learn about Einstein's theory of relativity. All right, so here are some of the important sections of the syllabus, which, by the way, I expect you to read. Okay, so online labs, what kind of craziness is that, right? So, you're not going to be able to set up the equipment. You won't be able to take data, except for today's lab. You will for the first lab. So for most of the labs, I'm just going to give you the data. However, you're still going to learn a lot. You'll still have plenty to do. I mean, you have to analyze the data, which is going to be answering lots of questions, graphing things, a lot of work to do. So you'll still learn a lot, believe me. Most likely, I may have a video for every lab, or I might provide photographs or something. And then we'll have a Zoom meeting to discuss it as well. Now, here's something that's important. In physics, the purpose of a lab is not to learn lab techniques like it is in chemistry, for example. The purpose of a physics lab is just to actually see how the laws of physics work and just practice with what you're learning in class. And so you will learn a lot, and it's going to be a very useful class. And so hopefully if you work hard, this should help your class grade improve. Okay, so everything associated with this class is on Canvas. And so the syllabus, every single lab, we have a lab handout, we have a data sheet. Sometimes I have some comments or handouts or whatnot. Everything is on Canvas. So you're going to be using Canvas a lot. Okay, assignments, so lab reports, right? So you are required to submit a typed lab report for each lab. Now, you don't have to type equations, but you can if you want to. It's not very difficult. The lab reports are due by midnight, Hawaii time, on the dates listed in the schedule. The schedule's in the syllabus. And you have to submit the reports on Canvas. No such thing as late lab. You submit it late, you get 0. Now, this is important. Every semester I say this. Every semester there's a few people who ignore it. I don't know why. The lab report should not repeat information already included in the lab handout, such as purposes, procedures, etc. In other words, don't hand in the lab handout. I wrote the lab handout. I don't need to see the purposes and the procedures and all that. I already know what they are, so it's a waste of time. It's called fluff. However, the report should include all the information asked for in the lab handout, like data tables, graphs, whatever, analyses, answers to questions, whatever it says in the lab handout, you provide. The most important parts of the lab report are the presentation of the data, the discussions of the results, and the answers to the questions. The data should be shown in clearly labeled tables and graphs when appropriate. Okay, now here's something important. For all calculations and derivations, you must always show your work. Always show all of your work. Okay, each student should write his or her lab report independently. Well, this is not, I should have erased this, right? I mean, when we were in class, we'd work in groups, so that's why I wrote, even though you may do the experimental work in groups, you should not turn in identical reports. If 2 reports are the same or almost the same, you get 0s. You have to do your own work. Grading. So you're really fortunate in this online situation. All right, so here we go. So every lab is worth 10 points. Now, you get 5 points for just completing the lab. So, I mean, if we were meeting face-to-face, that means, if you came to the lab and you completed it, you get your 5 points. Now we're doing this online, So these 5 points are free. Then you get between 0 and 5 points for the report. Okay, so let's talk about that. All right. So every lab report is graded on a 0 to 5 point scale. Every lab handout lists the point breakdown. I'll show you that later if I remember. All right. So in other words, on the lab handout, I say 1 point for this, 1 point for that, 1 point for that, whatever. So you always know what you have to do to get your 5 points. You earn 5 points by successfully completing the in-class lab, which you do, right? So, which means everybody gets 5 free points since this is an online lab. It's supposed to be a smiley face. I don't know why it didn't show up. So here's the grade assignments, just like in class. I mean, a lecture class. Okay, now this is just something that I wrote the first couple years I was here because I was frustrated, to tell you the truth. So lab report checklist. And this is just for reference. You might want to look at it the first couple times you submit a lab, but it's just, it's supposed to be helpful. Number 1, well, it's not number 1. Did I follow the directions? You better follow the directions. Number 2, did I answer all of the assigned questions? So in your lab handout, I have questions kind of scattered here and there. I mean, it's super obvious. I mean, it says like question number 1, question number 2, but if there's a question, you're going to answer it. If required, did I show my work? It's always required to show all of your work, even the trivial stuff. Does my report include the data? I actually had some lab reports when I was new here where people didn't include the data. So what's a lab report without data? Well, pretty worthless, right? Are the data tables properly labeled? So what I'm saying is, if you have a data table, you've got to label it so the person who's reading the report knows what it is. And you also have to include the units, like meters or meters per second, because if you don't include the units, it's useless. Are the graphs properly labeled? Same thing, right? You got to label your graphs. Do the fitting parameters have units? Okay, let's talk about fitting parameters. So here's a graph. I'm just making this up, right? So let's say this is, this is distance in meters, and this is time in seconds, right? So straight line, right? So we have y equals mx plus b, right? Okay, so so the y is distance, so this is in meters. Oh man, that's a slope, right? So meters. The x is time, so it's seconds. Now what has to be the unit of the y-intercept? Well, meters, right? Because meters equals meters plus meters. So this has to be meters. Now, this is the slope, right? Slope. So look, meters equals meters plus meters, right? I mean, that's the only thing that makes sense. So look at this mx thing here. So we have the slope, times the time, right? Times the time. Okay, now this whole thing has to have units of meters, right? Meters equals meters plus meters. So what has to be the units of the slope? Well, it has to be meters per second, right? Because, if this is meters per second and this is seconds, the seconds kill and you get meters, okay? All right, so meters, the slope is meters per second. The x is seconds, and that's meters. So again, just repeating myself. This is a meter. This thing here, meter per second times seconds, what's meter? And that's meters. Now, this says fitting parameters. What's a fitting parameter? A fitting parameter is what Excel gives you. So in other words, you plot the data, right? You plot the data. And then you say, okay, Excel, give me the equation of the straight line. So I'm just making up something. So Excel gives you this. Y equals 2.1x plus 0.1 or something like that, whatever, So this is the slope, right? That's the slope. And that is the y-intercept. So those things are called fitting parameters. They're parameters of the fit. Okay, so that's what Excel gives you, you know. And so, but, you know, Excel just says 2.1. It doesn't give you the units because it doesn't know, right? It just gives you 0.1 for the y-intercept. So if you were writing a lab report and you just said the slope is 2.1, that's garbage, right? Because a fitting parameter has units. What you should say is the slope has units. I mean, the slope is 2.1 meters per second. Or the y-intercept is 0.1 meters. Meters, okay? All right. We'll talk more about that later, but I just figured I might as well do it now. So again, let's say you are plotting a quadratic. So Excel would give you this, y equals ax squared, for example. So the a, you know, is the fitting parameter. And so it has units. So you also have to supply units. Okay, so let's see. Do the fitting parameters have units? So you better give me units when you give me a fitting parameter. Do my results make sense? Think hard about this question. Oh my goodness gracious. Please think about this, okay? If your results don't make a bit of sense, you're probably doing something wrong. So make sure your results make sense. I mean, here's what I'm talking about. So we have one lab, we'll do it later on, where we're measuring everybody's reaction time. So have you ever played the game? You take so somebody has a $20 bill. So pretend it's a $20 bill, and they go like this, and they say, if you can catch it, it's yours. But most people have a pretty, you know, most people's reaction time is like 0.2 seconds. And so it's too slow or too long, so you never get the $20 bill. All right, so we're going to measure the reaction time by doing this. So there's going to be a person who measures basically how far, you know, at the beginning point and the end point. So how far the ruler moves, you know. And then you're going to use some equations and figure out your reaction time. It's just like if you're driving and you see like an animal cross the street, you know, you slam on the brakes. Well, you don't do it instantaneously. There's a bit of a delay, your reaction time. Okay, so the first couple years I was here, we had groups of 4 people, and I had everybody doing it 10 times. So everybody in the group saw this done 40 times. 40 times, right? Okay, so like, I don't know, half the class or something like that, they made an error in their calculation, and they said the reaction time was 2 seconds. Now think about that. 1001, 1002. So what I'm saying is that's insane, right? And they saw it 40 times. How can you say 2 seconds, all right? And so, you know, don't just be a robot. I mean, if your results don't make a bit of sense, figure out why. That's the important thing. Do my conclusions follow from the data? You know, your conclusions better follow from the data. If they don't, you better have a good explanation why. Are the plots large enough for one to clearly see the relationship between the data points? So I'm going to exaggerate a little, but let me show you what I'm talking about. Okay, so let's say we have a graph like this. Real small graph. Now, what is that? I mean, is it a straight line, or is it like this? Is it you know, like is it a square root? I mean, what is it? You can't really tell because the graph is so incredibly small. So you know, make your graphs large. I mean, make them the size of a piece of paper, you know? So they should fill the width of a piece of paper. You also want really, really large graphs because then you can see, you know, if it's curved, if it's straight, whatever. And you know, this is online, right? It's not like we're wasting paper. So make your graphs big. Okay. Did I use the spell and grammar checker? Okay, now come on, this is physics lab, brother. What's your problem? Well, come on, everything you do is a reflection on you. If you're careful about something, it kind of shows that you care about it, right? If you do a rotten job and you have lots of spelling errors and grammar errors, what does that show? It shows that you didn't really care, you know? And come on, nowadays it's so simple. You push the spell check button. You push the grammar check button. It's a total piece of cake. So just get used to doing a good job. Whatever you do, do it well. Is the report neat? You know? So I have a grader who's going to grade these things. And, you know, if you can't figure it out, just mark it wrong. That's what I tell them. If you can't figure it out because it's a mess, just mark it wrong. Again, this is a reflection on your effort and how much you care about it, so make it neat. Okay, am I handing in a draft report or a finished product? Right, so all the last three kind of go together, right? Okay, so just do a good job. Okay. All right, that's it for the introduction.